I'm fitting some point motors here to operate a batch of points across the layout. All of these points are running between other tracks, so I'm not able to fit a surface mounted point motor like these. Here is my 1mm hole. Which I then vacuum up, ready to take my 1mm, or in actual fact 0.9mm diameter paper clip that I have bent to give me the right spacing here, so that this will go into the throw bar. Will it go first time? It looks as if it will. You can see the slight bend in the wire to reduce the dimension between those two vertical legs, and this will, he says hopefully, go straight in to the throw bar. If I go underneath and bend that paper clip to the right, now it operates this point. For all my other points, these are all the same. The next step in connecting up these paperclip linkages is to use a spoke from a bike, 2mm diameter, so I've had to open out the holes in the point motor to 2mm, and that really is only just big enough. I still have to use a rat tail file to make them usable. I've taken to using my vernier caliper to measuring what the throw is on the point motor, so that I can then identify whereabouts on the paperclip I need to make the operating point to get the right amount of movement to throw the point. Have I got that spoke anchorage too close to the pivot? I don't know, we'll find out in a minute. Next job is to mark the spoke at about the point where I need to bend it. If I have a choice, I have to make the length of the spoke here a fraction too long, if anything, because it's much easier to put a bend midpoint in the spoke to shorten it than it is to try and lengthen it. So that's the next job, bend the spoke and fit it in the hole. That section followed how I operate all my points mechanically and how I deal with the linkages. I now want to show you how I moved from motor-driven threaded rod drives for my point motors to servo motor drives with various types of instruction for the same. These are servo motors with the electronics cut away. I'm simply using the motor and gearbox in the servo, 2-wire control, and I'm using the same sliding PCB units that we used on the motor-driven threaded rod.
I've added a resistor and a switch to that circuit, and that's described on my webpage. And if I throw the switch, you'll see the servo move. And it moves quite precisely. I'd like to show you the modifications that were made to the circuit board to get this to operate. There's really nothing to it. There are 3 wires, or pins rather, that come through from the servo or the potentiometer on the back of the servo test board, and I've connected a black wire to the negative lead on that potentiometer, an orange wire to the center lead or the wiper, and that's all I bring out to the switch and resistor.
Point motor here used to be an H&M twin coil machine. It's now a servo motor controlled by a modified servo tester. The servo tester uses the circuit I showed earlier, where the switched resistor is in fact a potentiometer, so that I can change that at will. Here's the modified circuit tester using a potentiometer switched by a remote switch, which is over there. I moved forward to utilising a locally mounted relay to do that switching of, in this case, a fixed resistor. This is the original circuit I used for the servo controller. I've tried variations on this, as you can see from my drawing to the right, but this is the final version. I'll show you the next one in a moment. This is the final version of the circuit that I used, and you can see I've got a line through that one on the right, which was a variation of the same. This one shows the first style of servo tester I developed with a 555 chip and a single pole relay, where I had to use a little micro switch operated by the linkage itself to switch the polarity on the frog. This is one of the layout drawings I used to determine where I was going to put the components of that servo controller. I used a standard squared paper, and it looks a bit untidy, but that's how it was built. It shows the layout of the double pole relay and the connections from them, and the 555 chip at the bottom with the row of connections. The next step in my journey was to design this board for the 555 chip circuit and a double pole relay with two potentiometers that would switch the frog without the need for a separate micro switch. The operating switch on my control panel to the second siding in Banbury 2, operates the servo and the linkage. Now, my operating switch on the operating panel operates the relay here, and the relay sends the signal to the servo. As a matter of course, when I'm assembling these, I set the potentiometer to around mid position. These are 20 turn pots, so around 10 or 12 turns in from the end, so that this is about its central position, which means that when I mount this, I can mount this pointing straight up. You know how the horn comes away from the pivot point on the servo, going all the way round. There goes the point itself. And we'll give it another turn to make sure there's a positive operation. Now let's check that I've got the right one. The switch is down, which tells me it's switched to the siding. The rod is going away from us, but the point is going to straight ahead. So I've set the wrong one. Simple as that. So this one needs to be set on the other potentiometer. There. So clockwise rotation of the pot moves the arm further away from me, and that operates the point. Now we set the other one in the other direction, but I've already got it moving too far. So what we'll do is we'll turn that pot back to operate the point the wrong way, and now having thrown that switch to that position, we move the pot far enough to operate the arm far enough to operate the point, and give it another turn to make sure it's a good positive operation. Because invariably a change in the conditions out here, temperature or humidity, mean that the output from this, not being as stable as a commercially available tester, is likely to vary a little. And I know from experience that I've had to come back and twist these pots up to make sure that the point is in fact thrown properly. And there we've got the final setting. Now what I'm going to do is just make sure that I've got the right amount of movement, and probably give myself an extra bit of movement there, and an extra bit of movement there. Good positive operation. Right, how's that?